Welcome to the AP Chem 2022 FRQ video series. Today we'll be solving question 1 of the 2022 AP Chem free response questions released by the College Board. Whenever a question pops up on the screen, be sure to pause the video and read it to yourself first. In this question, part A gives us a student's measurement, a mole ratio, and also asks to calculate the maximum mass of salicylic acid crystals. This tells me it's a stoichiometry problem and even includes the word right here. So let's set this up and start out with the student measurement. And then we will now be using the molar mass that they gave us in the problem to convert from grams of salicylate to moles of salicylate. Now we will use the mole ratio that they gave us to convert from moles of salicylate to moles of salicylic acid. Now we will use the molar mass that they gave us to convert from moles of salicylic acid to its grams. And this is going to give us our final answer of 0.272 grams. Part B asks if it's reasonable for some of the salicylic acid to have dissolved, where we should turn our attention to the solubility in the table. And with these questions, it's important to answer yes or no first. So we'll start out by saying yes, and then we'll justify. And this is because the solubility in the table above indicates it to be slightly soluble in water. All right, so now part C requires a little bit of careful reading because it's easy to just jump to our heat equation, but if you notice, it is not just about heating. It also asks about melting the crystals too, which means that we have to account for a phase change. Okay, so the overall heat equals the heat from raising the temperature plus the heat of the phase change, which, if you can remember, is the heat of fusion, which is also very conveniently given to us in this table. It's almost as if they had planned it out. So now we will use the heat equation over here, so our usual heat equation added with a term to account for heat of fusion. So now most of these values we can just get straight from the data table or from the question, but the moles we will have to do a little bit of work to find that. So we are given the grams over here. So we are given 0.105 grams of salicylic acid. All right, and now we also have the molar mass given to us of the salicylic acid. So we will use that and some stoichiometry in order to find the moles of salicylic acid. So we can just punch this in our calculator and get this as our moles of salicylic acid, which we will just plug in right here. It's very important to convert this from kilojoules to joules, and that, if we punch it in our calculator, will give us our final answer of 37.1 joules. The next part of this question deals with intermolecular forces, and you must know that the one with the greater melting point, so in this case, salicylic acid, the one with the greater melting point is going to have the stronger intermolecular forces. So when I look at these structures, I can see that the salicylic acid has 2 hydroxyl groups, whereas the methyl salicylate only has 1. So that means that we can say salicylic acid has more hydroxyl groups, which gives it the stronger intermolecular forces, which means it takes more energy to break those bonds, giving it the higher melting point. We have a titration curve where we need to find the pKa in part E. So remember, for pKa, we're supposed to be looking at the half equivalence point. And the half equivalence point is where the pH is equal to the pKa. So first we find the equivalence point of 10 milliliters. That takes us to our half equivalence point, 5 milliliters, because we just divide that by 2. And then here we see that the pH is 3, which is also equal to the pKa. Done. All right. So now for part F, this is talking about a weak acid, strong base titration. So now what I can do is I can use our Henderson-Hasselbalch equation. And what led me to this thought was that, I was given the pH over here. I just solved for the pKa. So, this was the perfect opportunity. So now what we can do over here is we can plug in the pH, plug in our pKa, and then this is going to be our ratio of the conjugate base over here to our weak acid. So now what I can do is I can isolate this ratio. So that's what I'm going to be doing. I'm going to isolate the ratio. I can see that the ratio of the concentrations of the conjugate base and the weak acid is a whole number. So this number is greater than 0. So ratio is greater than 0. Therefore, concentration of conjugate base. So now part H is our last part, and here we are doing a second titration, this time using benzoic acid and comparing its curve with salicylic acid. Of course, the question wants us to draw the curve. So let's just take this, one important point at a time. First important point is going to be our initial, which they've already given us. So that's just going to be somewhere between 3 and 4 would be fine. And now we need to look at our half equivalence point. So something we need to know is the equivalence point is going to stay the same for both benzoic acid and salicylic acid. And now we have our pKa, which is going to be equal to the pH that we solved for in the previous part. So that's going to be about 4.2. So anywhere over here would be good. So this is going to be 5. So I'd say somewhere right about here. So now I'm just going to connect the dots. And now we're going to have this come up just like the salicylic acid. And that's your titration curve. That's all for this video. Thank you for watching and good luck studying.